Well, you know what they say, in for a penny, in for a pound. Or you might just say what it really is. I've opened Pandora's box. Hey there, welcome back to Farmcraft. I'm John, and this is a 1960 John Deere 1010. I lost my mind recently and decided I wanted to get this thing running again. What I thought would just be a couple videos has turned into a series. Let's do a quick recap. So I found it had a bad injection pump and also had low compression. In order to get it to run, I had to rebuild the injection pump, then heat the block with torches, adjust the valves, reset the pump timing, turn the starter with 24 volts, and use starting fluid. I did actually get it to run after a big struggle, but it smoked like a freight train. So I ended up pulling the head, pulled the pistons, and found that it had a broken ring, 2 pistons had cracked lands, and all the cylinders were glazed. I also inspected everything to see if it was suitable for a rebuild. The connecting rod journals, the cylinder bore, I checked the crankshaft, and I found them to be within the specifications, so that's when I decided maybe I can rebuild this thing. So now you're recapped. I got a lot to do. I want to get this thing running by the end of the video, so let's get into it. I've opened Pandora's box. So let me see if I can show you here. In between this, which is the reverser gearbox, and the engine block, there is a significant leak. Enough that it has oiled my floor. I didn't want to work on any of that stuff, but at this point, you've come this far, I'd be an idiot to not pull the engine and fix that leak while I'm here. I mean, I guess we've already established I'm an idiot for working on this thing in the first place, but since we've established that, we might as well roll on with it, right? I need to pull this engine. To pull the engine, I'm gonna have to pull the hydraulic pump off. At least I can get a new belt and get it on there when I put that back together. And then there's a bunch of bolts that go around this bell housing that is going to allow me to get that engine out of there. And while I have it out, I will have the easiest access to that starter that I will ever have, and I can get the starter off and look at the brushes and everything. So it's worth doing. You know, the other nice thing is Jennifer's actually going to pick up an engine stand for me right now. So I can put this on an engine stand, I can bring it inside my shop where it's not so darn cold and windy, and rebuild it in there. So now as far as the leak, my understanding is there's some kind of O-ring behind that. Hopefully that's going to be an easy fix. Like I said, Pandora's box. Let's get to work. That's nice. Won't go on there. I wasn't sure how heavy this thing was going to be. But it turned out it was pretty manageable. Yeah, going underneath. So there you can see all that fresh oil coming out right there. This one is going to be the hardest one. Grab a hammer. Got my hammer. Gonna be here a while. There's not room to do this any other way. Oh, you know what? I got a new tool. Be right back. My daughters gave me some ratcheting wrenches for Christmas. There we go. And of course, I'm going to leave this on here unless that bolt will come out. I don't think it will until I pull the block. There it is. So yeah, that's gonna stay there until I pull that block. At least the bolt's loose now. So I'm done down here. I can put a jack under this and get the rest of the bolts. That's going to be the last one I take out. I went ahead and rigged up a chain hoist there. So I've got that engine under it with the jack and over it with the hoist. It's not going anywhere except where I want it to. So you know what those jerks did? This is the rear cover of the engine. It has to come off too, which is probably pretty typical, but I really didn't want to have to do that because that means the starter needs to come off. And if you recall, I could not get this lower nut off of the starter before. Jeez, that thing is on there. So we're back to fighting with that. I was thinking I could get the engine out of the way and then have an easy time getting the starter off, but all right, here's the infamous starter nut. What? It's loose. How is that even possible? Yeah, it's spinning. That's interesting. I guess all the cranking and, you know, previously I preheated it and sprayed it with penetrating oil and then vibrated the heck out of it, getting this thing running again. Probably got good and hot while I was cranking it with 24 volts. It's loose now. I even had a plan. I was going to come at it from the front with a crow's foot wrench and use the impact to try to break it free. But I'll take this. This thing has been a champ. Can't complain about this at all. I can reach down in there and get that wrench and bolt off from before. You can look in there and see the flywheel. Oh yeah. I don't know if this jack is necessary. I mean, this thing's intended to go on the bell housing. This engine has this huge flywheel. That's a heck of a flywheel. I think that's going to work. Now you guys might notice that. And you might recall a certain previous video where I was taking a transmission out of a dump truck and a Harbor Freight jack just about dropped the darn thing on me. If you haven't seen that video, I'll leave a link here, I guess. That was intense. There's a couple reasons that I got this. Because I decided today that I needed an engine stand, and this is the only place that had it in stock. This thing's rated for 2,000 pounds. I don't know if I'd put 2,000 on it. I imagine this is somewhere around 600, but it's nowhere near 2,000. And this, I mean, you can look at it. You know, the welds are a little ugly, but they're gonna hold. And the way it's all bolted together, those are all 14 millimeter bolts. That's just not gonna collapse. There's no moving parts in this kind of thing other than the rotating. It's just a much more predictable beast than the jack was. So I was okay with this. I wanted to get one that was strong enough to handle what I need to in the future as well. So interesting, that pink paint that dripped out of the viewing hole for the flywheel. Not sure what to make of that. What are those? Kind of look like gear teeth, but that's just like a cotter pin under there. I'm not really sure what to make of that. So I'm going to clean this thing out and see if I can tell where the oil might be coming from. On the other side, we have this very beefy flywheel. That is a flywheel, man. Just a spline shaft in the center. So you may recall from our previous teardown, I had a couple of cracked lands in these pistons that I was going to try to fix by welding them up. I don't have a TIG welder capable of welding aluminum or any experience with it, so I sent these to my friend who's a professional welder, and he actually got some footage of the process of welding them back up. He removed the lands where they were cracked and then is filling the entire area back in so that I can machine it back to spec. At least that's the idea. He said they welded up good. He didn't hear any pops or anything. This one looks pretty good. Unfortunately, this one, now we both looked this thing over. This definitely was not there before. But this one has developed a crack. It's right there, goes down, and all the way through the wrist pin. Not the pin, but the piston where the pin rides. You see that? It comes right down through there, through here. You can see it pretty easily right there. And down into here. So that piston's junk. I'm not going to ask him to try and weld more and then have to remachine this out. And especially given that after some more work with the dealer, I was able to locate a new piston for $350, which isn't great, but that's reasonable. So I'm going to replace this with a new piston. Now this still has a pretty important use for me, and that is I am going to use this as a dry run on machining out these grooves. I want to see how that's going to go before I do this one, which looks really good. He nicked that land a little bit and filled that back in, but I should be able to machine this all right back to spec. And hopefully that's going to go okay. So then I only need to buy one piston, not two. It's $350. I'm using the 4-jaw chuck and a dial indicator so that I can get this thing running perfectly on center. Indicator movement means that it's off center, so I'm making small adjustments to the jaws until I can get the indicator running true. I think that's as good as I'm getting that. And I have to make sure it's running true on the front face as well. See, I'm just barely scraping the land there. So I don't think I want to go any further than that. Houston, we have a problem. Now, I knew this, but my parting tool is too big. Just barely, actually. But I knew I had this, which is for boring internal grooves. The only way I'd be able to use it, because of the way the tool is set up, I'd have to cut on the backside here. I could do that, spin the lathe backwards. But it's not deep enough. It doesn't reach the bottom of the grooves. I hadn't thought about that. I figured I'd end up using this, but this is not going to work. So I need a thin parting tool so I can get in there and cut out those grooves. Darn it. So I ordered one, and it arrived, and it's also 1/8 of an inch. The description was wrong, and I'm really tired of waiting. I have this parting tool. It's high-speed steel. And it's 1/8 of an inch as well. Won't fit, but high-speed steel is wonderful because you can shape it how you want. I'll get on the belt grinder. I'm going to bring this down so that it's less than 100 thousandths. Make sure it has a little bit of an angle to it to keep the clearance, and sharpen it up just like this side is. You just sharpen it right on a grinding wheel, and I should be able to part it off with that. I'll just flip this around. That's why it's good to do a dry run on a junk part. It's deflecting away when I try to cut this edge. I'm not really sure what to do about that. I shortened the amount of stick out that's on the tool and went ahead and tried the second groove to see if that would go better. Still had some problems with flexing though. So I learned something. So the way the parting tool works, I can cut this edge. I can push that way against that edge and get a good cut. But if I pull and try to cut on this right side of the tool, it flexes. So what that tells me is that my plunge cut needs to be right on that side. When I do the first cut, I need to take time and make sure I get it exactly where I need it. Then I can push this way and get this side. So yeah, I think I think we can do this. Now this one was a dry run. Those grooves aren't perfect. I don't care. I know what to do now. So this is going to determine if I need to, well, spend another $350 on a second piston, or if I can get by with just one. And really, if this was a really valuable machine, I'd just go ahead and buy a new piston. But a big part of me just wants to know, will this work? And I think that's as close as we're getting. As usual, I wish I knew what I was doing. This right here will be fine. That side is going to be tough. I don't know how this side of this land is going to do. Hopefully it won't be flexing. It'll be a deep enough cut. These I'm pretty confident in. I think I can get those right. So, yeah, let's give it a go. Not much to lose here, other than 350 bucks. Just scraping that edge. Right now I should be aligned with this edge, and then I will come over and get that edge. Let's see. So now I want to go in and get it on the far wall. Right there. So this measures 105 on one of the ones that I have. I'm at 108. So I think for the type of repair I'm doing, I think that would be fine. So let's go to the next one. All right. So I don't like that. Part of that land is not there. In spite of that, I bet you this thing would work, and for a long time. Because the ring gets driven down against the land, and that side of the land is nice and flat. And there is plenty of meat there. And obviously, the way it was running with the land cracked off. So, yeah, I think this would work. Oh, I'm an idiot for working on this old machine. I've finally made a decision. These pistons have been a huge barrier into me proceeding forward because I haven't been able to figure out the best way to go. Even though these were welded up, I don't think either of them is usable. One, obviously, because it has a crack that goes down through the wrist pin that's just not going to last. And you got to think about this. If the piston breaks, it's not likely to just need a new piston at that point. It's probably going to destroy the block or need new sleeves, or, you know, it's going to do a lot of damage. So, you know, I can't just throw this in here and run it until it fails. If it fails, then you've ruined the engine, most likely. So, yeah, I could. It wouldn't be the end of the world, but why do that? That's stupid. This one has a couple spots like that didn't weld that well. And, you know, that's something that happens, I've heard, with old aluminum. It ends up getting inclusions, it gets messy, so as you're welding it, even though it looks good, you end up with pockets in it. And I've got another little one there, and some right here. And would those necessarily affect the function? I don't know. There's another one there. But there's just too many of them. And then this land didn't fill all the way. Yeah, there's another little pore right there. So what did I learn from this whole process of welding up these pistons? I learned several things. One, that pistons oftentimes are not round. These pistons are, for the most part, round. From here out, they are. So that made this much more doable. The skirt is actually wider there than it is there. And the reason for that is because as the piston heats up, it's going to heat differently and become round. You don't want it to get too oval shaped when it gets hot, and then obviously you don't want it to bind against the cylinder wall. Anyway, that's not the barrier on these pistons, but if you're trying to fix old pistons, you might check and make sure that they are round before you even consider it if you're going to turn them on a lathe. Several people in the comments, people that are like heavy equipment mechanics of 30 years experience, said that welding on pistons like this is pretty common. So this was not like a ridiculous hack repair. And I would definitely consider doing this again in the future. Now, what would I do differently? One, I would want to have my own TIG welder, because for me to go back to my friend, have him drive back to work, try again, come back, it's just too much. I need to get a TIG welder if I'm going to do this in the future and get good at welding aluminum. The other thing is I would make sure that I have a grooving tool that is exactly the width that I need for the rings. Because trying to do one side and then the other side with the flex, it worked, but it didn't work that great. I think it would have been better to have the right tool. What this all comes down to is I don't think I want to use either one of these pistons, unfortunately. And in spite of that, I really want to thank my friend for welding these up. I think given what he had to work with, he did the best job possible. It's just these old things are just tough. You know, it's hard to weld on this kind of stuff that's been banging around in an engine for the last 60 years. They have the part number cast right on the side of the piston here. It's a T16026T, and I ran that by the dealer, and they came up with this. The problem is, let's count. 1, 2, 3, 4. 1, 2, 3. It's a different piston. This is a redesigned piston that was used in later models of this machine, and it's what I'm supposed to substitute for the part that I have. No one seems to really know for sure on what you do as far as the rings. The ring set has 3 compression rings in it, and then this is the oil ring. So the oil ring is going to go on the wide groove there, but I only have 2 compression rings on this new piston. So which rings do I use? Well, the dealer didn't know, and I haven't been able to really find anything online, but I did find something in the service manual, and I think I have it figured out. The good news is the rings are a good fit in the grooves. They are the same. One of these rings has a slight angle on the outer profile, and I can barely see it myself. I don't think I'm going to be able to show it on camera. But that is the one that gets left out. That's the bottom ring on the ones that I have. So, yeah, this one would go in like that, and then this one goes in on the top. So that'll be my main compression ring. This will be ring number 2, and then this is oil ring. These 2 pistons are getting scrapped and replaced with those 2 pistons for the low price of $356 each. I really didn't want to have to do that, but what was I saying? In for a penny, in for a pound. And I have to say, a bunch of audience members, without me asking to, just gave me money and said, put this towards getting the old girl back in action. So, you know, you guys really helped take the pain out of this this price tag right here. So, yeah, I'm fine with it. Let's start working on getting this thing back together. All right, the first thing I want to do is the engine block, prepare the surface for the head gasket, hone the cylinders. I want to scrape this head gasket surface. There's some areas with rust and still some gasket stuck on it. I'm going to do a little sanding on this block to get it flat. Same with the head. And these dowel pins are really in the way. It'd be nice if I could get them out of here. Without destroying them. So I'm going to turn down something on the lathe so that I can put it in there and then really grab that and not crush it. There we go. It's going to make getting that gasket material off of there easier, but more importantly, I'm going to be able to take a big flat surface over that and make sure it's flat. Now, that may not look super pretty, but it feels nice and smooth. And the nice thing about this is the service manual actually calls for using a Permatex sealant on each side of the head gasket. So you do have a little bit of wiggle room. So that's a piece of granite. It's not a surface plate, but it's pretty darn flat. I actually got this from a guy I used to know that made gravestones. This was a piece of scrap left over. And he gave it to me, and I've used it as a flat reference surface several times in the past. And you can just put PSA sandpaper on it. There, I've got a 220 grit flat reference surface. So I can see I'm touching pretty well there. A little bit here, I'm still a little low. I'm definitely low there, and that's where it was leaking. I'm good there. A little low here. So I'm just going to work on this for a little while, sanding it up, or down as the case may be. Yeah, I think that'll do it. I've got contact all the way around. I guess this is the lowest spot right here, but I still have contact, and with a little sealant on there, that is going to do just fine. Yeah, that's looking really good. Alright, getting ready to do some honing. Now this is the worst one. That's the one that has the scratches in it from the broken oil ring. And I've got about 5 thousandths to work with. That should be plenty. So I'm going to use WD-40 as honing oil, and we're going to hone that out and see how it looks. You just need a light oil to hone. You want something to lubricate it. It doesn't need to be... It does need to be something that'll spray though. Yeah, that's going to take a while.
Two 2,000 years later.
It's making a nice crosshatch, you can see, in contrast to that one. It's still all glazed. I think that's going to do it. That looks really good. Actually kind of surprised how much that's showing up on camera. It feels perfect. And I think at this point I'm just wearing my cylinders for no reason to get rid of a line. That's not going to affect anything. So I'm good with that. Alright, I got a bore gauge now. And I've got this set to the nominal size of the cylinder, which is 3.625. So what that means is if this gets to 0, that would be exactly 3.625. So I am about 6 thousandths under right there. And according to the specs, I can go up to 11. You can see each line is half a thou. 45 to 0 is 5 thousandths, so I'm 6 thousandths away from nominal right there. And again, I can go up to 11. So this is fine. That's well within spec. And of course at the bottom of the cylinder there's less wear, so I'm only like 0.04 away there. So even after all that honing, I still have plenty of meat left in this, which is really nice. Now that I've got that all honed like I want it, I don't want any condensation getting on it and rusting, so I'm going to put a good coat of, this is just Rotella engine oil. Next we're going to do cylinder 2. This should be a lot faster, but you can see all the glaze in there, see how it's shiny and all the vertical lines. We'll take that off. I don't think it's going to, let me not jinx myself, because that one took a long time. Kind of see there where it's starting to hit the sides in some places and not others, so yeah, going to take a little time. So it's looking good, but I still have a little more to go, I think. Although it might be fine like it is. You know, the only thing that gets to that area is the top ring, and there's another ring under it. And most of these cylinders, there's actually 2 more rings under it, so it probably doesn't matter. I don't know. More experienced guys out there, what do you think? Regardless, I'm going to be here honing cylinders, and we'll see you back. So the cylinders are done. That dark band at the top there it looks worse than it is. You can't feel it, and the crosshatch partially covers it, so yeah, I'm good with it. I honed these quite a lot, actually. Wore out one set of stones and half through the other set, all the honing I did on these. Cylinders are done, and they look good. So I've got it flipped over so that I can clean up this oil pan gasket. For right now, I just want to get most of this grit out of here. I'm just using clean diesel fuel to just kind of flush it out. Yep, now I need to work on this head and the valves and all that good stuff. Don't need that. That thing really does not want to come off of there. I do not have a ring compressor, a spring compressor tool. Might finally need to buy one. I've always been able to manage without it. Got it. So if you haven't done valves before, at first this is kind of confusing how these things work, and a lot easier to show you with the spring not in the way. So on the valve stem there are 2 grooves, and these little keepers also have some, it's not a groove, it's the opposite of a groove that fits in there and will lock in place when you get it in the right spot, like that. And these are also cone shaped. The spring will come up around them and hold the keepers into position. So it's the spring tension basically pushes the keeper in, and these make it so that the spring can't come up past the valve. So the spring ends up pulling the valve in this direction. We flip that guy up. That's that valve that I was just messing with. So now there's no spring, so it'll stay down. If the spring was and the keeper was still there, it would be pulled into that position. So they default to closed, and then when the camshaft lobe hits the push rod, which hits the rocker arm, which pushes down on the top of the valve, it opens. And that's pretty much it. So I'm going to take all these guys out of here. Come on. These keepers don't want to come out, so when I compress the spring down, doing it one-handed, it's tough. So I need something to help me with this, and I can tell you already, getting it back together is going to be even worse. So I'm going to make something to help me get these springs off. You know, I could go to the auto parts store and probably find a spring compressor tool, but for one to have that much reach and that much height, it's a pretty big tool. I don't know. It's going to be faster for me to make something. So I found this piece of shaft. Don't know what that was from. Something I tore apart. These holes are just for the head bolts, and they're 5/8, and this is a 5/8 shaft, so that fits perfect. So now I need to drill a 5/8 hole in that, and then shape the end of this so that it'll fit that valve. Be right back. Drilled a couple holes in it. So now I need to make it cam in this hole that the shaft is going in. So I push it down and then just put a little bit of sideways force on it and it stays down. So I should be able to get the keepers off. And there you go. That worked remarkably well. Certainly a lot cheaper and a lot faster than getting a tool. Alright, so now we can get a good look at these valves and the valve seats. They actually don't look too bad, but will definitely benefit from a good lapping. And obviously I'm going to clean this whole head up. But like this seat here, there's the valve for it. Not too bad, but could be better. And then this seat here, there's the valve for that. So something I'm curious about, so a good measure of how well sealed they are is if you can push down and spin them. And yeah, I can spin that one easily. Can't spin that one. So that means it has more contact, and yeah, that one spins really easily. That one's a little harder to spin. Can't spin that one. Or that one. Or that one. Or that one. Yeah, so definitely some worse than others, but we're going to lap them all. Now the first thing I'm going to do is, because I can carry the head around, it's a lot easier to clean than the block. I'm going to bring this up to the house in my laundry sink with some degreaser and some good hot water, and I'm going to wash the heck out of this thing.
John, why is that in my laundry room?
You'll be alright. So there you go, nice and clean. Now I do want to surface this head just like I surfaced the block, and I'm going to do this differently rather than using the stone, because I can pick this up and carry it to a flat reference surface that I have upstairs. Yeah, I've definitely got some highs and some lows. So, I'll be sanding on this for a little while. It's actually going pretty fast. You can see I've got pretty good contact out here, here, here. Still a little bit low or high, if you want to say that, there and there. And yeah, I haven't been at this that long. So that tells me this thing was pretty darn flat as it was. So a little bit more and we'll be good to go. And wouldn't you know it, while I was leaning over and pushing this head back and forth, I started to develop a kink in my lower back. It really wasn't too bad at first. I took a break, but it kept getting worse as the day went on, and by the end of the day, it was pretty bad. So if you're wondering what took so long on this project, let's just say back pain and engine rebuilding don't get along. I think that's going to do it. Now we need to do the valves. I want to clean up these valves, and I also want to lap them in, and to help me, I want to spin them with a drill. Now, you can just chuck the drill over the valve itself, but rather than doing that and potentially scratching it up and causing issues, I found a piece of fuel line that fits over the valve and also a little rod that I can chuck. So basically, the fuel line acts like a little coupling. So now I can chuck that, spin the valve, get it all cleaned up. Use a little WD-40 on it, and we'll clean all this crud off of it. Makes pretty quick work of it. One down. Look at that one. She's looking nice. It's a pretty striking before and after. I think you guys get the idea. I'll see you back in a little bit. Alright, so now we need to lap them in, and that means putting some abrasive paste on the little angled surface there, and also on the head. The surface that matters is that angle right behind there where it contacts. So we need to grind those two surfaces together and get them nice and shiny and smooth so that it seals well. And obviously you want to do the valve that goes in that position. So I have my valves arranged just like it is in the head. Permatex valve grinding compound. All right, little compound just goes right around there. Put this drill on the valve stem there, and then I can grind it. Really looks ground all the way around. Yeah, it looks pretty good actually. Yeah, I think I could use a little bit more on that side. Relatively clean rag with a little bit of oil on it to really get the rest of that abrasive off of there. You do not want to use too much and let that get down into your freshly honed cylinders. That's like the worst thing. It's made to abrade metal, and you do not want that in your cylinders. That's for sure. Let's see how this valve seats. Oh yeah, can't spin that. I think that's good. It's got some pits in the valve seat. Not too bad. Looks pretty good. There's still a couple pits on it, but it has a nice wide ring to seal all the way around. And the part on the head looks really good. So I think you get the idea. I'm going to grind in all these valves. We'll bring you back. All right. All the valves lapped in well. And head looks really good. We're getting ready to start putting this thing back together. Here's another thing I really didn't want to do. The rear main seal is behind here. I have to take this driven disc off. I have to take the flywheel off in order to change it out. I got the seal. It came with the gasket kit. So I'm at this point, it would be really stupid not to change this seal. But Pandora's box. So this driven disc is centered, and there's a special tool that you put in there to center it. And of course I don't have that tool. So what I'm going to do is use a paint marker, and I'm going to trace around it and basically try to put it back exactly where it is now. We'll bend lock tabs. So I've got to come along rigged up just to support that thing. Trust me, in a fight between the flywheel and my back, the flywheel wins. Do not think I have a puller that'll work on this. Hey, look at that. Pop off of there. I think it is. Watch your toes. Occasionally things go easier than expected. Rear engine cover just has one bolt. That's the rear main seal. Pandora's box. Now this seal isn't leaking, or at least it is a little bit oily. I don't know. I've got to replace it. I'm here, but if I take this thing out and the new seal is not the right size, like happened on my dump truck, I don't know. That's gonna stink. New seal. New seal is in. That's going to work just fine. So there's no torque spec on these, so click, click. All right, I can sleep better now. The rear main's done. I want to start getting this head back together. Now, I'm going to oil these a little bit as they go back together. guide seals only go on the intake valves. It kind of makes sense because when the exhaust valve is open, the exhaust chamber has high pressure. So the oil is going to get blown back into the crankcase any little bit that gets through that tiny gap. Whereas the intake has a negative pressure and it will actually try to suck oil into the combustion chamber. So it makes sense that you'd want to seal the intake better than the exhaust, and that's exactly what they do. Most modern engines will have seals on all the valves, but this isn't unheard of. This is a clean rag. Drape this over and let it sit while we're working on other things, just so we don't get dust and everything, all that oil that we just put on there. Alright, so I am ready to start putting the pistons back in. But before I do that, I want to get this thing as cleaned out as I possibly can. So I'm using some clean diesel fuel and a blowgun and a brush, and I'm just going to try to really kind of douse everything in it. Have it all run down into a catch pan underneath. Get all the junk out of this block. Any abrasive left over from me honing the cylinders. All that junk. This kind of highlights the importance of a break-in oil change too. Because no matter how good you are, there's always going to be some junk in here that you'd rather wasn't. And no matter how good the factory is, the same thing. So after this thing runs for the first hour or so, I'll get the oil all good and stirred up and change it. So I'm going to take my time, listen to an audiobook, and get this thing clean to my liking before we start putting it back together. I'll bring you back. Alright, this is cylinder 1. I'm going to go ahead and oil it. Make sure we have plenty of oil in there. That's the front. Pips on the right, so this goes like that. So I got these rings from Area Diesel Service. You know, they've been super helpful in me doing the rebuild as well. They found new rings for me, got me a new set of glow plugs, and they also rebuilt the injectors. So this thing's going to run like a top when I get this thing back together, I think. And a lot of that is thanks to Area Diesel Service. Thanks, guys. So there's the oil ring. So there's 3 types of rings. This one is chromed. That is the top compression ring. This one has a little kind of cutout in that corner, and that is the middle compression ring in that orientation. And then the bottom one, it has a tiny little bevel to the outer face. And that ring was eliminated on the newer pistons, so I will not be installing that in the pistons that we replaced. I didn't show that well at all, so here's the service manual. It shows you that the top ring is a rectangle. The second ring down has a little groove in the upper portion, and then the last ring has a slanted portion on the outer face. Second ring. Get a little more oil on those. Recall on the last video on this machine, I checked the wear on the connecting rod bearings with a bore gauge and a micrometer as it said to do in the service manual, and I found that they were right at the upper limit of spec. Basically 4.5 thousandths, so I am just at or above the upper limit of spec on this. So that's not ideal. So I got some new ones and I'm putting them in. Kind of a little hump right there and a little notch right there, so you put it in like it looks. Alright, so I've got the crankshaft journal up. The front is this way, and the pips are supposed to be on the right side, and they are. Well, I'll tell you what, the crankshaft journal for 4 is also up. So let me go ahead and put that one in. That's one of the new pistons. So that's the one we're going to leave out the third ring. If you can probably see what I'm talking about down there. There the journal is facing away from us, and here it's facing towards us. So just because of the order of firing of these cylinders, the middle two are companion cylinders, and then 1 and 4 are companion cylinders. Okay, front, right. Everything has a specific orientation as you're putting it together, so you have to pay attention. The piston has to point in the right direction towards the front, and the connecting rod has a specific orientation right to left. So I'm just paying attention to that as I put these together. Put in the snap rings and make sure that they go in the grooves. You certainly wouldn't want to find out later that you missed one of those. And then the oil ring, it's a 3-piece ring. I'm putting the, I don't know what you'd call that, the wavy ring on first. And then these thin rings are made of steel, and they're too thin to use with my ring expander tool, so I have to do them by hand, and they're a little bit fiddly. You just put one thin ring below and one above the wavy ring, and that's it. So I've got the bottom one on, now fiddling with the top one. And that'll do it. So now the 2 compression rings, I'm skipping the third ring down because there's only 2 grooves. So this is a redesign of the piston that was used after the first couple years of production of this engine, and they eliminated one of the grooves. That means it has thicker lands. I suspect I wasn't the only one to have cracked lands on the pistons, And that is why they did this redesign, to make the land stronger. This top ring has a chromed outer edge and is the main compression ring. And of course, I'm staggering the gaps on all of the rings. Front. Huh. You could kind of say I did those backwards, because now it's harder to get to the caps. Thinking backwards. So let's spin this. And as we're doing it, we're going to need to bump these down. There we go. There is the connecting rod that we just put in. That's piston 4. We'll put a little oil on that. And here's the cap. We'll oil this as well. So let's get a nut on that one before we lose it. Now we will be torquing these, but for now I'm just going to snug them. Okay. I'll go ahead and put the crankshaft where I want it, which is going to be like that, and we'll flip it back over. And repeat. Right. "40 to 45 foot-pounds is what it calls for. Alright, pistons are in. That's a nice hurdle to have out of the way. I want to put the oil pump back on, but it has to be in time. And it meshes with the gear up in there. So the camshaft is being driven off of the crankshaft right here. And then of course the camshaft is down in there. Right there on the camshaft there is a gear that mates with the oil pump and drives it. And here's the gear that mates with that on the oil pump. Now of course the oil pump doesn't need to be in time, but this gear is what drives the injection pump. The timing of the injection is all mechanical on this machine. There's no computers, so if this is not right, the machine won't run. This has a little pip on it, and that, once it is installed and fully bolted down, that needs to be pointing in a 45-degree angle towards piston 4. This is 4. This is 1, which is at top dead center right now. Now they're helical gears, so as this goes in, it's going to spin a little bit, but it's supposed to end up somewhere like in that position. So let's see what happens. You can't see anything when you put it in. In my view, this is an odd way to establish the timing of an engine. There are no timing marks on the gears. They have a special tool for it, which I'm sure they don't make anymore. And of course I don't have that tool, but I should be able to do this based on what it says in the service manual. It was upside down and my mind was tricking me. So that dot on the end of that, I think you can, yeah, there it is. The dot needs to be pointing directly at cylinder 4. And it is clearly not. It did take me a few tries though. Well, I wish I had something more definitive to go on, like an actual timing mark, but that's definitely at 45 degrees. It's pointing towards cylinder 4. And I tried moving it one tooth over, and it was almost vertical at that point. It was nowhere near 45 degrees. And then same when I moved the other way, it's nearly horizontal. You know, it says get 45 degrees and have it pointing towards cylinder 4. Well, I hope that's right. Otherwise, I'm going to be back in here. All right, this is getting exciting. We are ready to put a head gasket back on here. Now I want to brake clean this surface and get all the oil off of it, but I don't want to take the oil out of the cylinders, so I'm going to use a rag. Now I need to put these alignment dowels back in. So same thing with the head. So one thing with this gasket is it calls for this Permatex number 3, which is the aviation sealant, a non-hardening sealant to be used on both sides of it. Come right here. So I'm going to go ahead and put the sealant on that side, and then I'll flip it over and do the other side. Now this is not RTV, it's not silicone. So for torquing a head, you have to tighten the bolts in a specific order to a specific torque. And I tend to come at that torque slowly. So here I'm just snugging them up. Alright, so that was only 44 foot-pounds. That's whatever the torque wrench was on. We're going to 150, so I'll do 100 next. Alright, 150. Well, I don't need to go to the gym today. The head is on. What do you think? Hopefully that thing's not going to leak. That would stink. Now, after, I think the manual says after 2 hours of running, I'm going to have to pull that head again, pull the valve cover again and re-torque those head bolts. So the first 5 push rods all look great. The last 3 just have this very superficial rust. And I don't think it'll make any difference in function, but I'm going to clean them up on the wire wheel. And we're going to get some oil on them before we put them in. Now I kept these organized so they're going back in the same holes they came out of. And this is the rocker arm assembly. It transmits the force that the camshaft puts upward on the push rods over to a downward force onto the valves. So now when we spin the engine over, the valve should move. It's interesting, that valve is tighter than it should be, and I haven't changed anything except pulling the head and putting a new head gasket in. Yeah, that would do it. And sanding the head and the block down. Yeah, shut up, John. Haven't done anything. Go ahead and adjust the valves. I'm not going to cover this in detail in this video because I've already done this, and if you're interested in the exact procedure on how this is done, go back through the series. I'm going to get this done and I'll bring you back. Man, we're getting somewhere today. So I got 4 new glow plugs, courtesy of Area Diesel Service. And here's where Area Diesel really came through. It turns out that this injector is totally obsolete. You can't get parts for it. And I had no idea what to do with these things. But Curtis over there figured out that you can actually take them apart further than I already did. If you've seen my previous video, you know I took this apart and tried to clean it out. And he opened it up and actually lapped the seat and the plunger, I think they call it. I don't know. They made a really cool video on it, and I will leave a link to that in the description. You guys should go over there and check it out. He was thinking that he was going to have to like modify an existing injector to get one that will fit in here, but he was able to take these and fix them. So And the spray pattern's beautiful, the opening pressure is good. So yeah, these things are good to go. Actually, I think I'll... Click. All right, getting somewhere. It'll never be that clean again. I figured that thing wouldn't be flat. That's why it was all gooped up with RTV. Let me see if I can make that thing fit a little better. So every bolt hole is raised. I can feel it. Well, that's a lot better. Tiny bit of wobble, but not much. I'll take that. Now, beating on it, I did leave a couple of marks. Alright, you can see where I had some high spots and a little low there. I hit a little bit and hit there. There's no wobble at all now. And you know, this is just an oil pan. These low areas will pull in to the new gasket and I think we'll be just fine. And if I have any leaks, I'll have to pull it and do some RTV, but I don't think so. I think this will work. Never going to be an easier time to put this pump back on. Engine's at top dead center. The timing mark behind here is also at top dead center. So I'm pretty sure I offended a bunch of people with my ineptitude at lock wire. So I watched a video. Let's see if we can do a little better. Everybody happy now? Click. Well, if I'm not mistaken, and there's a good chance that I am, that engine's ready to go back on the machine. So I got a problem. This video is getting too long, but there's a lot more to do. I have to work on the starter, I have to work on the generator, I have to do some stuff with the wiring, I've got to replace the reverser seal, I've got to change a hydraulic line, I've got to put the whole cooling system back together. All sorts of things that need to happen before I can try running this thing. So I'm going to focus this video just on the engine. The next thing you're going to see is me putting this engine back on the machine, and there's going to be a bunch of other stuff that just magically happens. and then we're going to try to start this thing up. I think the other stuff I will film and put in a video next week, because there's a lot to do, and it should be pretty interesting. But this video is getting long enough. This engine has a cast iron valve cover. It's big, heavy, and strong, so there are actually threaded holes in it that are intended to use for lifting the engine. On a modern valve cover, most of them are just pressed sheet steel. You wouldn't be able to do that. 12,000-pound chain, 2 half-inch bolts, and a 2,000-pound hoist. And this is just a hitch from an old tractor, but it's made out of 3/8 plate. I don't think any of that's going anywhere. And I guess for those that might be wondering, that strap is probably 20,000 pounds. That is an oak 2x10. Did I do 2x10s or 2x8s? It might be 2x8, but it's a true 2x8. And it's right beside that massive beam. This thing is engineered to be able to hold 2.5 feet of snow on it. So, yeah, this little engine is not anything to that. So I put a come-along, which is just anchored to the back, on the chain that's supporting it so that I can move it that way as needed and not have to fight it. My goal right now is to get this engine in, but my even bigger goal is to do it without hurting my back again. Let's look in here and see if we can see what's going on with this thing. Why don't you want to go together? Yep, it's together. I have to say, that is a handy thing. All right, so now there's a dowel pin right there. I can see it needs to come down just a little bit. Bring it down just a hair. Let's see if we can twist that in there. It went in. Get a bolt in there, at least get it started. Here. Nice. So now the dowels can't come back out. Get the rest of these bolts in here, and the engine is back in. So let's get some oil in this thing and fire it up. It's going to start right up, right? Yeah, nothing with this old pig is easy. I'll go into all the details in the next video. but I did eventually get here. Boy, that was close. Alright, now we expected the smoke. I oiled everything. There's plenty of oil in the upper end of those cylinders, and the rings need to seat. So yeah, that's all expected. We're going to have to run it for an hour or so. I'd like to see it calm down. Little blow by. Remember how that was smoking like crazy before? Sounds good. Smoky for now. And it still wouldn't turn off when I turn off the fuel. Previously I was turning it off by covering the air intake, but my new air filter setup is not tight enough. It continues to suck air in spite of covering it. I think it's just burning the engine oil that's getting by the rings that aren't set yet. I hope. So I had to undo a hose clamp and cover it like I was before to turn it off. So before I get too crazy, I want to make sure that we're cooling okay. Well, it's been a half hour. It's better than it was, but it's still pretty smoky. Look at that! You know, they talk about cars, you need to drive them like 100 miles, so that's a lot of running. Well, it actually turned itself off that time. Yeah, so I need to do a proper break-in on it. The problem is, I'm waiting on a hydraulic hose, so I can't really take this thing out and drive it around. So I'm afraid I'm going to have to sit here and wait until that hose gets here before I can do much more with it. It's not good on a break-in to just run it at a constant speed without load. You want to run it at a lot of different speeds and under load to try to get those rings to set. And I must say, it's fairly disconcerting to see all that smoke. I mean, I knew it was going to smoke, but you know, this is my first rodeo with a big engine rebuild like this, so it evokes some pain to think it might continue to smoke in spite of what I did. That said, the blow-by is very different, and the amount of smoke is also very different already. So obviously I did something. Anyway, I'm going to shut it down for tonight, and I don't know when I'll see you back. I might have to wait for that darn hose. Well, there you go, guys. It runs, but there's still a lot more to do, and I skipped a bunch of stuff to get to this point. I worked on the starter, on the generator, on the radiator, having some kind of issue with the glow plugs. A lot of things that I still need to work out. I need to do a proper break-in on it, and I need to see if it's going to stop smoking so much. I would really like to get this thing running like I expect a diesel engine to run. You know, when it's freshly rebuilt, it shouldn't be smoking, not that you can see. But this is an old diesel, so that's a question for you guys out there. Is it reasonable to expect this thing to not smoke at all? Is it just a matter that the rings need to be seated? If it's not, I do have some other ideas. We'll get into that later on what could be causing it. So, and I have to confess, I thought to myself, oh, we'll just pull the pistons out, put new rings in it, hone the cylinders, lap the valves, and throw it back together. That won't take very long. It just never works out that way. You end up doing a million other things just because you're there and you really have to. Replacing seals and stuff, I could have skipped that, but that didn't take very long. There's just a lot involved in doing an engine rebuild, even a partial rebuild like this. Don't get me wrong, I'm glad I did it, and I'm going to continue to work on this thing. I'd really like to get it running tip-top. We'll see if we can get there. But I've learned a lot, I hope you have too, and I kind of consider this a dry run for a potential engine rebuild on another dozer that you might have seen in the past. Maybe, maybe not, I don't know. Not anytime soon. Once I get done with this pig, I might need a little break from that. But I got a million other things in the works, so more on the way. And don't forget to hit that like button, subscribe. Doesn't cost you a thing, really helps out the channel, and it's much appreciated. We'll see you guys on the next one. Big Mama 49 and 53.